Hello and welcome to our video on sampling plants and organisms living in an environment, and the required practical, which is going to be on the exam, both the higher and the foundation tier, which is a required practical 7. Before we begin, it would be useful for you to have a pen and a sheet of paper handy, so that if you are asked to pause the video and have a go at any questions, you are able to do so. So, very quickly, we're going to have a little look at what might be in this particular topic. So it's part of the ecology topic, and we're looking at random sampling and quadrats first off. We're going to have a look at the methods that are used to be able to carry those out, how we can improve accuracy of the experiment, and how we analyse the data. Okay, there is quite a lot in this one today, and I have a feeling it might be quite a long one. But we know that it's on the exam, so it's going to be really useful for you to have a watch. So when we're talking about a population is all of the organisms of a particular species in a given area. All right. So if you're looking at a population of woodlice, it's all the woodlice. If you're looking at a population of all the daisies, it's all the daisies. All right. All one particular species. To estimate the population is a little bit more complicated than we'd like it to be, but there's a solid method that we're expected to know for the required practical, which you're then meant to be able to use. So we ideally don't want to go out and have to count the entire field's worth of daisies, because it'll take a very, very long time. We could count instead the numbers of species within small sections of the whole area, and then times the amount of area that you've already looked at by the number that were in the area that you've already looked at by the size of the entire field. So in this case, we could use, let's say, 6 quadrats here, and we're going to put them in those 6 places, and they're the only places that we're going to count daisies or dandelions or whatever it is that we're looking for. We could then calculate and multiply up to the whole area. So let's say this area was 100 meters squared, and each of these is a 1 meter squared quadrat, then we have looked at 6 meters squared. If there were an average of 10 daisies per meter squared, so we counted 60 daisies in 6 meters squared, then we're expecting that to continue, that trend to continue all the way up to 100 meters squared. There's 10 per meter squared, so there would be 1,000 in the whole field. All right, would be the idea. So this is a quadrat. This is what a quadrat looks like. They can be smaller. We can look at some that are maybe only half a meter by half a meter, 50 centimeters by 50 centimeters. I have a feeling that could be this one here that we've got in the picture, because obviously it's only got 5 boxes along, so each of them might be 10 centimeters by 10 centimeters. Some of the quadrats you might use in school might be up to a meter by a meter, so they might be significantly bigger. It's a square frame. What is a quadrat was a question that was asked not that many years ago on a GCSE exam, and it's a pretty tough one, because if you've never really, you might know what one is, but if you've never really considered how to write that down, then it makes it really complicated. So it's a square metal or plastic frame, further divided into lots of smaller squares. So when we're doing this, the problem's going to be that if you're looking for daisies, you could potentially put your quadrat down only where there are daisies, in which case, instead of finding that on average there was 10 daisies per meter squared, we might find that in every single one of your quadrats there was 40 daisies per meter squared. That's not what everybody else is finding. That's because you've chosen the areas that have the most daisies. So that doesn't really work, okay? One of the things that we have to start thinking about is, where are we going to put these quadrats? And we're going to do that using a random sample. All right. Just to kind of highlight this point here, looking at the 2 pictures at the bottom, in the one on the left hand side, if we were to place the 3 quadrats there, you're going to find very, very few flowers growing there. But if you look at the picture on the right hand side, you get significantly more by putting the quadrats in those locations. So it's best done by taking your entire area and actually starting to map it out, drawing a grid of the entire area. If we can measure the length and measure the width, we can then assign them either letters or numbers. So we can have meter 1, 2, 3, 4, 5, 6, 7 down the side, and meter 1, 2, 3, 4, 5, 6 along the top, etc. Okay. What we can then do is, once we've got this down here, is you could use either a random number generator, or even if you've got 6 numbers like we have on these sides, you could even use a dice, okay, which will give you a random number. You roll that dice twice, you get 2 random numbers, and you can use that like coordinates. So if your first dice rolls at 3, we're going to go along the top to 3. The second dice, the second time you roll it, rolls at 5, so we're going to go all the way down to 5, and we're going to put that quadrat there. You can see in that one there, if we went along the top to 3 and along the side, down the side to 5, we would have no daisies in that quadrat. So we've got to use that dice or that random number generator. And one of the things that people really commonly think is that if they either stand in the field facing the opposite way and throw it backwards over the head, or if they spin around in circles before they throw it, then they're now taking a random sample. You're not. You're still choosing which direction you are throwing it in. By doing it this way, using dice or a random number generator, we can guarantee that the quadrats that we put down were in random places. So we can then go on to estimate a population. Okay, we need to know the area of the quadrat and the area of the site that we're looking at. We're going to divide the area of the site by the area of the quadrat, which is how many times bigger it is. So if the site was 100 meters squared and your quadrat was 1 meter squared, then 100 divided by 1 is 100. This quadrat would fit into that area 100 times. We're going to place the quadrat randomly. We're going to use either a random number generator or dice to be able to do that. And then we're going to count and record the number of organisms. We're going to take at least 10 samples. There's a bit of a balance to find here. If your area is 10 meters squared and you have a 1 meter squared quadrat, then by taking 10 samples, you have actually sampled the entire area. You've done every single part of the area, and you've saved yourself absolutely no time whatsoever. If the area was 400 meters squared, you probably want more than 10 samples. If you've only done 10 meters worth of 400 meters squared, then your answer might not be particularly close to what the real answer is. It might not be very representative. So we're going to work out the mean number of organisms in each quadrat, what the average number was across all 10 of them, and then we're going to multiply up to estimate the total number in the site. So if we had an area of 50 meters squared that we're sampling, and we've taken 10 meters squared worth of samples, if we found 6 of each organism on average across those 10 samples, then we need to know how many there would be. We would times that 6 by 50, okay, to be able to get 300 is the idea. So again, we've just got an example on this one here that we can just have a little look at. If we have a half a meter by half a meter quadrat, one of the really common things people get wrong here is they think that is a half a meter squared. It's not. It's a quarter of a meter squared, 0.25 meters squared. Do 0.5 times 0.5 on your calculator if you need to. We then find the site area. So we've done 35 meters times 12 meters for this particular field would give us 420 meters squared. The multiplication factor, therefore, this quadrat would go into that field 1,680 times. If we take 10 quadrats and we find that on average there were 4.5 daisies across those quadrats, then we need to do 4.5 times the 1,680. That would be how many times that quadrat would fit into that field. In which case, if there were 4.5 per quadrat, we would expect to get 7,560 daisies for the entire field. So we have a second example here, and I'm going to give you a chance to pause the video and actually have a try at working this out for yourselves. We've got a 0.5 meter times 0.5 meter quadrat. Remember to check how big that quadrat actually is, because it is not a half a meter squared. And it gives you the number of daisies down here per quadrat across the 10 quadrats. You've got the size of the field at the bottom, 24 meters by 10 meters. Have a go, please, exactly the same as the last one. Pause the video for now, and then we'll come back and we'll do some answers. Okay, so first we're going to find the quadrat area, 0.25 meters squared. Then we're going to find the site area, 240 meters squared. We're going to find out how many times that quadrat would go into that site, which would be 960 times. The mean of the daisies is 5.1 if we add all of those numbers up and divide it by 10. And then finally, we estimate the size of the population, which means we have to times it by the number of times that it would go into the area, or the multiplication factor. 5.1 times 960 gives us 4,896 daisies. Okay, a couple of points about improving the accuracy of this experiment. Remember, this is your required practical. Um, if we use a bigger quadrat, we are more likely to include the organisms that we're looking for. So rather than using a quarter of a meter square quadrat like the one that you were using in the previous example, and actually finding that it sits right in between all the daisies and therefore you don't find any, in a bigger quadrat, you'd be more likely to actually catch some daisies where you put it down. The more quadrats you put down, the more representative your sample is. If you were to do 20 quadrats, 21 meter by 1 meter quadrats in a 20 square meter field, then actually you've done the entire field, and your answer should be extremely representative, okay? Because it'll be right. You've counted every single daisy. Of course, that's crazy. And finally, you need to make sure your samples are random to avoid bias, because otherwise you might just deliberately avoid the areas where there are no daisies because you're not going to be able to count anything. The problem with that is that there are still areas in that field that have no daisies, and your answer will be too high. So we've got a kind of a broader question this time round, and I'm going to leave this one at this point here. Describe how you would estimate the population of daisies in a field, and include how you would make your results as accurate as possible. So this is the whole thing we've been looking at so far, all right, from start to finish. And it's a description, a method. I'm going to ask you to pause the video here, and then I'll be back to do some answers in just a sec. Okay, so some of the things that we should have mentioned. Um, to sample the population of daisies in a field, you'd place a grid over the map of the field. We're going to use dice to generate random number coordinates. We're going to place the quadrat at the coordinates, count how many daisies there are, calculate a mean, multiply to get the estimate of the number of daisies in the whole field. And then we're going to make sure the results are as accurate as possible, because we could use a large quadrat and place it down a number of times, a reasonable number of times. Don't just do it once or twice. Okay, so just due to length of this topic and the amount of information that needs to be in it, I've split this one across two different videos. So there is a second video which is simply titled Sampling 2, and I would advise that you watch that one now that you've finished this one. As usual, thank you very much for watching. Good luck with your revision, and bye-bye for now.